Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to determine some characteristics of geometric figures. You're successful at today's lesson when you have determined through an investigation just some of the characteristics and properties of geometric figures. To start off here, go ahead and grab a sheet of graph paper would be best, and draw 3 points and connect them just like I've done here to form a triangle. Once you're done that, measure the length of each line by just putting a ruler along that, and put a dot exactly where the midpoint of that line is. So if I put a ruler along here, and if let's say that line ended up being 10 centimeters, I would look at where 5 on my ruler is, and I'd put a dot right there. Once you're done that, for each dot, using the corner of a sheet of paper, draw 3 right bisectors, one for each line. And so what I mean by that is I'll take my sheet of paper, or any other sheet of paper, put it on top of this one in a way that the edge is right along this line, because of course that corner is 90 degrees. And I'll put the corner exactly where this point is, so that the sheet of paper is sort of like this, and that would help me draw the right bisector, just like that. And of course, I want you to draw 3 of these, one for this side, and then repeat that step for this side. So that would be that midpoint and the right bisector. And a third one on this side, and that's that midpoint and that right bisector. Go ahead and complete that. And when you're done, answer this last question here. What do you notice? Pause this video for as long as it takes for you to do that, and then resume. All right, just before we continue, I'd like you to do one more thing. I'd like you to try your best to draw a circle that intersects all 3 of the vertices of this triangle. All 3 of these vertices. Well, hopefully you were able to draw a circle sort of like this, right? So that's my circle. It goes through all 3 of the vertices. And now what do you notice? What do you notice happened? Well, one thing that I certainly note was all 3 of my right bisectors happened to intersect at one specific point right there. And actually, if I go from this point, I can use that to help me draw this circle, because this point does look like it's at the very center of that circle, as you can see here. This point has a very special name. It's called the circumcenter. The circumcenter of a triangle is the point where all 3 of the right bisectors of the triangle sides meet. A point where 3 lines meet is called a concurrency point. So the concurrency point of the right bisectors of the sides of this triangle is the circumcenter. And we call it the circumcenter because it's the center of the circumference of that circle that can go through all 3 of the points that triangle has. Next up, we'll move to quadrilaterals. So now, again, I'd like you to draw 4 points, and 4 random points anywhere. Just try to make sure they're exactly on the grid. That'll help us out later. And use those to form a quadrilateral. The quadrilateral should have non-parallel sides and not equal side lengths. So if you end up finding a quadrilateral that seems like 2 of the sides are parallel or 2 of the sides are the same length, then just move one of your points to make sure that is no longer true. And I'm going to show you an example of that just now. So that's A, B, C, and D, and I'm going to connect all of those to form a quadrilateral. Go ahead and pause the video and do that. And then what I'd like you to do is just follow the rest of these instructions and resume the video when you're done. Okay, so the second instruction here is measure each side and put a dot where the midpoint is. So this side, I actually don't even need to measure it to find the midpoint. I can see that, the rise between A and B is 3, and the run is also 3. So the midpoint will be at sort of 1.5 units down from A and 1.5 units to the right, and that's right over here. And I can repeat that for all 4 of my sides, of course. Right? So for B, instead of going down 5, I'll go down 2.5, And instead of going to the left by 2, I'll go over to the left by 1. And right there, that's that midpoint. And I can repeat that for all of these. Now I'm going to connect each midpoint, so let's say this one, to the two midpoints on the sides adjacent to the side that it's on. So this is the side that this midpoint is on, and I'm going to connect it to this midpoint and this midpoint. And I'll do that for every single midpoint. So I'll end up with this shape in the center. What do you notice? Pause the video here and write down anything that you might notice. Well, one thing that I notice is that the top and the bottom sides here are really, really flat. I think they're actually horizontal. And these sides, even though they're slanted, they look like they're slanted in the same direction. So one thing that we might discover out of this investigation is that the mid-segments of this irregular quadrilateral form a parallelogram. Now you probably drew a different quadrilateral than I did, and any quadrilateral that doesn't have any equal sides or any parallel sides, we would call that irregular. And because you and I might have drawn completely different irregular quadrilaterals, if we both ended up getting a parallelogram, and I hope that you did too, that's sort of the start of a pattern, right? Do all quadrilaterals form a parallelogram by connecting their mid-segments? A mid-segment, of course, is a line like this, a line that connects the midpoint of two adjacent sides. If that's true, then this might be something that we may be able to use later on. So by exploring these sort of connections between all of these very interesting properties of geometry, like the midpoints or the right bisectors or any other important lines or points, we might notice some of these interesting patterns start to emerge. And some of them that we have discovered in mathematics so far is something like the concurrency point of the right bisectors of a triangle is the center of a circle that intersects all three vertices, and that is called the circumcenter. And we did that during our Minds On. We also have discovered that the mid-segments of any quadrilateral can be joined to form a parallelogram. And some more that we haven't explored in this video, but certainly that are true and have been discovered elsewhere, is that the centroid, and I hope you recognize that word from our introduction to the unit, the centroid of a triangle can be found at the concurrency point of the triangle's medians. And again, I hope you recognize the word median from that introduction as well. The median of a triangle also bisects the area of that triangle. Other things might be that the other patterns might be that the diagonals of a parallelogram bisect each other, or even that the line segments joining the midpoints of the non-parallel sides of a trapezoid is that line segment's length is actually the mean of the parallel sides length of a trapezoid. So remember, a trapezoid has two parallel sides. If you take those two parallel sides and you find their mean, well, that's the same length as the line segment that joins the midpoints of the non-parallel sides. And that line segment actually also will happen to be parallel to those parallel sides of the trapezoid. In this exercise, this example, I'd like you to go ahead and follow these instructions. And you might need a pair of scissors, certainly a pencil or a ruler to do this. I'd like you to draw a triangle on cardboard and cut it out. Pause the video here for as long as it takes for you to do that. So you might end up with a piece of cardboard that looks something like this. Now go ahead and draw a line from one of the vertexes to the midpoint of the opposite side. So I'm going to choose this one right here, and I'll draw a line right to the middle of the other side. This line is called a median. And now go ahead and using a ruler, try to balance this triangle on the edge of your ruler along the median. Oh, when I tried to do that, it was not easy, but certainly it was a lot easier than trying to balance it anywhere else. Go ahead and repeat this process of drawing the line for the other two medians. Repeat step 2 for the other two medians, and then try to balance the triangle on the centroid. And the centroid is the concurrency point between these three medians. And then ask yourself, what might this exercise show us? Pause the video here and go ahead and do that for as long as it takes you. So one thing that I noticed, even when I just did this, is that the triangle was balanced on the left and right side of the ruler. And the only way for that to be true is if the weight or the mass of the triangle on the left was exactly the same as the mass on the right. And because the triangle's, cardboard the whole way through, its density is probably the same everywhere. The only way for that to be true is if the area of the triangle was the same on the on one side of the median as it was on the other. Now as I repeat that step to draw the other two medians, there's my midpoint going right across to the vertex, and then the midpoint of this side going right up to the vertex right there. If I try to balance this triangle on the centroid, and the centroid again is the concurrency point between the three medians, so right over there. If I try to balance that on the tip of a pencil, I might find that it's a lot easier than trying to balance the triangle anywhere else. Anywhere else and it tips over really, really quickly. But if I put it here, I'm able to sort of get that triangle to stay flat. What might that show us? Well, this point, the centroid, is actually the center of the triangle's entire mass. So if I had, a certain, you can see here we have 3 points on the edge of the triangle, but there are really an infinite number of points inside the triangle. This point right here, the centroid, is the average of all of those points. It's the in between of every single point that would be on the inside of the triangle. It's the center of the triangle's mass, or the center of the triangle's area, to put it another way. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.